Hello and welcome to this new tutorial. In this one we're going to add the last tokens to our two previous dictionaries that we just created, and these last tokens are the ones that are useful for the encoder and the decoder in the sec-to-sec model, which are, the start of string that we're going to encode by SOS, the end of string that we're going to encode by EOS, the pad, which is very important for our model because the process training data and the sequences in the batches should all have the same length, and therefore we have to input this token in an empty position. And eventually we will create a last token, which we will call out, and that corresponds to all the words that were filtered out by our two previous dictionaries. Thanks to these dictionaries, we know which words are not 5% least frequent words. So later on in one or two tutorials, we will use these dictionaries to replace all the words, all these 5% least frequent words by this token out, so that these 5% least frequent words are all replaced by one same common token, which will be out. So that's why it's very important for us right now to create these tokens and, of course, add them to our two dictionaries, questions words to int and answers words to int. So let's do that. Let's start by creating our list of final tokens. So we're going to name that list tokens, and remember a list is in square brackets, and inside we just need to input these tokens. So the order is important here, otherwise this won't work given the sec-to-sec implementation that will follow. The first one should be the pad. Inside this pair of symbol we input what we want and we will call it pad. Alright? Then the next token should be the end of string, which we also need to put in quotes and in these math symbols. So the end of string, we're going to call it EOS. That's the classic way to call it. You will see that in a lot of papers and a lot of documentation. EOS, end of string. Then the next one will be the token by which all the words that were filtered out by our previous dictionaries will be replaced. And as we said, we want to call it out, as in filtered out. So out. And finally, the last token we need is the start of string, which, remember in the intuition lectures, is the first token that should start in the decoding layers. When we decode the output of the encoder, which is the context, well, the first element of this decoding is the start of string. That's very important. So that's why we need to include it right here, same in quotes and in these math symbols. And we're going to call it the classic way, SOS, start of string. All right, so we have our tokens and now we just need to add them to our previous dictionaries. So now we're going to make two for loop, one for loop for the questions words to int dictionary and one other for loop for the answers words to int dictionary. And this will be the same for loop, so we will just do a copy paste once we make the first one. So for, then, well, we want to basically loop over all these tokens here. So the loop variable is going to be called token. For token in tokens, very simply, then colon, and inside we just need to add each one of these tokens to our questions word to int dictionary. And you know how to do this. The trick is just to take our dictionary, questions words to int. So I'm copying this and I am pasting that here. Then in square brackets, I just need to enter this new key that I'm creating, that I'm adding to my dictionary. And this new key is the token we are dealing with right now in the loop. So that's the key, because remember, the keys identifiers in the questions words to int dictionary are the words, that is, are the tokens. And then the values are, of course, some integers. Remember, it maps the questions words to a unique integer. So what integer could we choose here? Well, it must not be one of the integers created here in this previous code section, in this for loop here, but very simply we can just take the max plus 1 of all the integers that we created here. And since these integers were added from 0 to 1 to 2 to 3, etc., well, we can simply take the length of the questions words to int dictionary, because the length of this dictionary corresponds to the total number of keys of this dictionary, and that is the total number of values. And since we counted from 0 to this total number of keys, well, we can simply take here the length of this dictionary plus 1. And with this, we'll be sure that we have a unique integer for our new token. So I'm going to add here len, then I'm going to paste my dictionaries again, and I'm going to add plus 1 as we just said. And that's it. This loop is done. Because when we're done dealing with this token here in the loop, we will get to the next token, but the length of the questions words to int dictionary will have changed because we will have just added a new token, and therefore we're safe here. The next token will have a new unique integer. So that's perfect. That works this way. And simply we can move on to our other dictionary for the answers, which is answers words to int. And as I said, it's exactly the same logic. We just need to copy this, paste that here, and just replace question by answer. There we go, answers words to int, and same here, answers words to int. All right, and that will do it. So now we simply need to select these lines and execute. There we go, we now have our final tokens, the essential tokens for the sec-to-sec model, added to our two dictionaries. Perfect. Now we're going to move on to the next step, which will be actually very quick and easy because we just need to create the inverse dictionary of the answers words to int dictionary. And why do we need to do that? That's because we will use this inverse mapping when building the sec-to-sec model. So we simply need to do that quickly, and then we'll move on to the last final steps of data preprocessing, and we'll quickly get to part 2, building the sec-to-sec model. So I can't wait to get there, and until then, enjoy DeepNLP.